All right, so today we're going to be going over how to use the wave equation. So we started going over the wave equation back in early February, but everybody needs a little bit more practice on it. Okay, so the wave equation is represented by v equals f times lambda. Velocity is equal to frequency times wavelength. So v is your velocity. It's represented in units of meters per second. F, or sometimes the Greek letter nu, like a curly V with a tail in the end, is your frequency. It's represented in units of hertz, or capital H, little z. It's capitalized because it's a person's name. Lambda, that is the Greek letter lambda, represents wavelength. Wavelength is measured in meters or lowercase m. So, whenever we are solving for one of these variables, we have to plug it into this equation, and we need to make sure that we're using these units right here. All right, so let's look at some problems relating to this. So these are going to be coming from the wave calculations worksheet that is on Google Classroom. Okay, so the first problem says a sound wave has a frequency of 3,250 hertz and a wavelength of 0.1 meters. What is its velocity? So the first thing we want to do, we want to write down our variables. V, F, and lambda. So it tells me it has a frequency of 3,250 hertz. That's my F, 3,250 hertz. And a wavelength of 0.1 meters. What is the velocity or speed of this wave? So what I'm going to do is I'm going to take this information and plug it into that equation right there. So let's take a look. Okay, so that's step one, write down your variables. Step two, plug it in. Okay, V, I don't know what V is. I'm just going to leave it like that. Is equal to frequency is 3,250 hertz times 0.1 meters. Okay, so my velocity, if I multiply 3,250 times 0.1, is going to give me 325. And if we are dealing with velocity, our units are going to be in meters per second. It seems like scam callers will never leave you alone, even during a quarantine. Okay, so that is how to plug in if you are solving for velocity v. Okay, let's look at another problem. Okay, let's go on to problem number 2. Okay, problem number 2. A sound wave travels with a velocity of 330 meters per second and has a frequency of 500 hertz. What is its wavelength? Again, we're going to start out by writing off my variables. V, F, and lambda. Okay. So, a sound wave travels with a velocity of 330 meters per second. And has a frequency of 500 hertz. What is its wavelength? All right, so I have that now. I have my variables written down. Let's solve for this. Now this is going to get a little bit more complicated. Okay, V is 330. Is equal to F is 500 times lambda. I I don't know. I don't know the wavelength. That's what I'm solving for. Now, I have my information plugged in. However, it's not as simple as just multiplying this time. In this case, I'm going to have to divide. So I want to get lambda by itself. So I need to get rid of this 500. I'm going to divide both sides by 500 to get rid of that. Okay? So that my answer is going to be lambda is equal to 330 divided by 500 is 0.66. This is in my wavelength. Wavelength uses units of meters. Okay, so my answer is the wavelength is 0.66 meters. Okay, let's do one more. Let's see how to solve for the frequency. Okay. Let's go ahead and save some time, write this down. All right. Let's do problem number 3. A wave at sea travels with a velocity of 25 meters per second. If it has a wavelength of 10 meters, what is its frequency? All right, so it tells me the velocity is 25 meters per second. It has a wavelength of 10 meters. And I'm looking for the frequency. Okay, so let's plug this one in. So V is 25 is equal to frequency, I don't know, times wavelength is 10. Again, it's not as simple as just multiplying. In this case, we have to get rid of that 10 to get F by itself. So let's divide both sides by 10 to get rid of that. Okay, so the frequency is going to be equal to 2.5 hertz, because hertz is my unit of frequency. And that's all there is to the wave equation. It's basically just being able to identify your variables based on either the unit or based on context clues within the word problem, plugging it into the equation, and rearranging to solve for the unknown value. So if you look on the worksheet that I've posted, it's got some triangles on the top. It says wave calculations worksheet. It's got some triangles with like some pink colors for whatever you're looking for. It has the equations rearranged for you if you want to use those, or if you want to use my method where you use the V equals F times lambda equation every single time and you just rearrange, that is fine as well. Just know that you will be provided with this equation. I won't always provide the rearranged equation, so you do need to know how to rearrange it on your own. But if you're at home, you can use either method. Okay. So that was the wave equation. Okay, so that helps out with that. Let's look at the other equation that you're learning this week, which is the frequency period equation. Okay, so this one is slightly different. On this one we're just going to call this the period equation because it is solving for the period. And a period, in terms of a wave, basically is the amount of time that it takes to complete one cycle. Okay, so a period equals time to complete one cycle. Okay, that means how long does it take to complete one lap? How many times, or how long does it take to complete one loop around the sun? How long does it take to get one full wavelength through? That's what a period is. So the period is related to the frequency. So my equation is going to be frequency is equal to 1 over the period. Okay, period is represented by a capital T. I don't know why they chose a T. They just did. Okay, so that's my period equation. Frequency is equal to 1 divided by a period. You can also rearrange this to give you period is equal to 1 over frequency. So they can switch. Okay, so basically it's the inverse of whatever it is that you are given. So let's take a look at some problems related to period. Okay. Let's see. I'm trying to find some good ones. Okay. So right now I am on the period worksheet on Google Classroom. So this is for, it says wave calculations number 2. Okay, so let's look at problem number 9. Okay, so I'm looking at number 9 right now. Okay, so number 9 says ocean waves are hitting a beach at a rate of 2.5 hertz. Okay, ocean waves 2.5 hertz. I need to find the period. Okay, and obviously the problem is a little bit longer than this. I'm just paraphrasing it. Okay, so it tells me that's the frequency. I want the period. So this is pretty easy. Okay, I'm going to use my equation. Frequency equals 1 over period, or alternatively, period equals 1 over frequency. Since I'm solving for period, let's use the one that solves for period. Okay? T is 1 over frequency, which is 1 over 2.5 hertz. 1 divided by 2.5 hertz is 0.4. So my period is 0.4. My unit for period is going to be seconds. Okay, so that's 0.4 seconds, not even 5. Okay. So that's all it takes to solve for the period. Let's see. Don't see too many more of those. Okay. So if you're solving for period, you would use the one that solves for period. If you're given the period and you're trying to solve for frequency, you would use the one that solves for frequency. Either way, it is doable as long as you go back to one of these two equations. They're the same, just rearranged. So let me know if you need any extra help on this. I did host a Zoom meeting on this yesterday. Unfortunately, nobody logged on. So just email me if you have any questions. And you are going to have a quiz on this. Okay, so just make sure that you understand how to do these problems and that you can do them on your own.